Good day, my dear students and viewers. You are welcome to the studios of MathsX. We are still on set theory. In our previous video, we were on properties of sets. We talked about the identity laws of sets. We talked about the domination laws of sets, the idempotent laws of sets, and also the complement laws of sets. In today's video, we are still on the properties of sets. We will talk about at least 5 other properties of sets. I would want to urge you, my dear students and viewers, if you do find value in what we do here in the studios of MathsX, we urge you to please subscribe to our videos. Let us begin. Thank you. Let's look at the eighth law, the eighth law or eighth property of sets, and that is the double complement law. That is number 8, the double complement law. Or property. Pardon my writing it down here, but I'll take off that part of the board. It's pretty simple, my dear students and viewers. If I have a set A and its complement, and then I have the complement of set A. The complement of set A is set A itself. If I may show this to you mathematically, what was set A originally? Set A, my dear students and viewers, is 1, 2, 3, 4. So a set containing those 4 elements, 1, 2, 3, 4. What is set A complement? Set A complement, my dear students and viewers, will be 5, 6, 7, 8, 9, and 10. Then again, the complement of set A complement. So complement of this, it still falls back to the universal set. So by universal set, but from the universal set, what we have there is 1 to 10, right? But here we have 5 to 10, 5, 6, 7, 8, 9 to 10. So what is the complement of this? The complement of this, my dear students, is our 1, 2, 3, and 4, a set containing those elements that I had earlier mentioned. All right, so by that, if I was to describe this in Venn diagram form, I would have again my set A, my wonderful set A, my universal set, and that is it. And this is the region that fits this bill, where set A is exactly. Let's go to our 9th property of set, my dear students and viewers. Our 9th property or law of set is called the absorption property or law. That law states that if I have set A union A intersection B, that this will give birth to our set A. This is for its union. So the union of the absorption law is this. By this, let's start with this. We've done this before. That first of all, A intersection B, my dear students and viewers, will be our set A, which is 1, 2, 3, and 4. And then, of course, our intersection of set B is 2, 4, 6, and 8. That's what we'll be using. So clearly, my dear students and viewers, the intersection of A and B will be a set with elements 2 and 4 inside it. So what is our A? Our A, again, my dears, coming back here, our set A is 1, 2, 3, and 4. Then, of course, the union of our A intersection B, which is a set with elements 2 and 4, that is 2, 4. My dear students and viewers, and if you look very well, what is our union? A combination of all the elements inside 2 or more sets without a repetition. So when you put that down, we end up having a 1, a 2, a 3, and a 4, which is what we have up there. This is for its union. Let us describe its intersection. It looks very much like this, just I will change these 2 symbols. So we have here that A intersection A union B. A intersection A union B is still going to be an A. Proving that law, let's start with our A union B. Our A union B, my dear students and viewers, excuse me, our A is 1, 2, 3, and 4. The union with B is 2, 4, 6, and 8. So that the union of the union of A and B will give you a set, pardon me here, with elements 1, 2, 3, 4, 6, 8. That's what we have there. Now let's pick up set A. Set A, my dear students and viewers, is 1, 2, 3, and 4. Then intersection of the union of A and B, which is 1, 2, 3, 4, 6, 8. So what is intersection? What is common to two of them? What is common to two of them, my dear students and viewers, will be our 1, 2, 3, and 4. And this is still set A. That is what it is. Let us look at their Venn diagram description. Two sets, set A and B. That's my A and my set B. My mother set, our mother set rather. So for both of them, the region that describes this is here. For both of them, incidentally, they have one Venn diagram. So first of all, this is the intersection of A and B. Then union A, it's still this region. Also, the union of A and B would have been everything here between A and B, but the intersection of what? A is only going to give birth to A. So funny enough, both of them have the same Venn diagram, both the union and the intersection. Let's look at the 10th property of set, and it's called the De Morgan's law. So De Morgan's law. De Morgan's law of the De Morgan's property of set or law of sets. The De Morgan's law in its union states that A union B complement will be A complement intersection B complement. That is the De Morgan's law. And we will prove this. First of all, our A union B is here. We had that this A union B, we had our 1, 2, 3, 4, 6, 1, 2, 3, 4, 6, 8. That's our A union B. Then the complement of our A union B, going by the mother set, which is 1 to 10, will be our A union B complement will be 5, will be a set with elements 5, 7, 5, 7, 9, and 10 itself. That is our complement of A union B. That's what you will get. So I picked it from here. We already did our A union B, and then we now went into is what? Complement. So what we know what complement is. All these things were explained in previous videos. You would do well to check back. All right. Now let us look at our A complement intersection B complement and see if it flows with this. So first of all, we know that our set A is a set containing elements 1, 2, 3, 4. All right. So complement of set A will be a set containing 5, 6, 7, 8, 9, and 10. All right. Then also our set B, we know, is a set containing even numbers 2, 4, 6, and 8. All right. So our B complement will be 1, 3, 5, 7, 9, and 10. That is our B complement. Then let's talk about their intersection of A complement intersection B complement. I'll wipe off this part of the board. So our A complement intersection B complement. Looking at this, we have 5 first of all is common, 7 is common, 9 is common, and of course 10 is common. So if you look at these two, they are very much the same. So that is for the union of the De Morgan's law. Let's look at the intersection of the De Morgan's law. The intersection of the De Morgan's law states that if I have A intersection B complement, that this will be A complement union B complement. So let's pick out these things. First of all, our A intersection B, if you can cast your mind back, was a set containing 2 elements, and that is 2, 4. So our A intersection B was 2 and 4. If you can cast your mind back, we did that earlier. Therefore, its complement, which is A intersection B complement, falling back to the mother set, we are dealing with a set containing elements 1, 3, 5, 6, 7, 8, 9, and 10. This is it. Then what is our A complement? We had that here. And our B complement, we also had that here. So our A complement union B complement, it's just to pick up every element that was here. So we're going to have, first of all, we're going to have 1, 3, 5, 6, 7, 8, 9, and 10. That is our A complement union B complement. As you can see, both of them are the same. The next two laws, that is law 11 or property 11 and property 12, are not really very strong for me, because for me they pass for a mix of previous laws that we have talked about, and that is the law of the empty set and the law of the universal set. The union and intersection of those particular properties of those sets had already been highlighted in other laws of set that we had earlier talked about. Sincerely, these two last laws, they're not strong for me. They seem to be repetitions of other laws or properties that we've already talked about, as you will see in a jiffy. For law 11, the law of the empty set. This states that A union an empty set is an empty set, and this law has already been highlighted previously in the identity law. Also, it states in its intersection that A intersection an empty set is an empty set. This has already been highlighted in the domination law. So this particular law, for me, it passes for repetitions from other properties of sets. Let's look at the last, and certainly not the least one, which also has the same character of this law 11, and that is the law of the universal set. The universal set. For this particular law, it states in its union that A union a universal set is the universal set. If you look at this particular law, this particular expression, if you check back in your domination law, you will also see this expression. So that's why I said that this last laws, 10 and 11, or last properties of sets, 10 and 11, they are repetitions. Also, if you have in its intersection that A intersection, a universal set, is set A, and that is what it is. Understanding what union and intersection is in sets, you know that this whole sway. So going through the rigmarole of putting up an example, I think is needless. If you check also our identity property, you will see this also. So for me, laws 11 and laws 12 are not the most strong laws. So that is it. My dear students and viewers, this is it for properties of sets. We trust you've been enlightened on all the 12 properties that we have talked about, all in our 3 videos. In our next class, my dear students and viewers, we will be using Venn diagrams to solve mathematics problems. Until we meet again, my dear students and viewers, keep watching the videos of MathsX, like and share. As you do so, God bless you. Thank you for your time.